So Mark Shead, courageous software delivery, and personally, I got so pumped when I read this title because I feel that we are sometimes missing this kind of attitude when we want to go and make our lives and everybody's lives better. So, stage is yours, Mark.
We're going to be talking about courageous software delivery, which really comes down to rapid delivery with low risk. And so I want to just get a feel for what people think of when they hear the word courage. When you hear the word courage, what is it that you think of? And the link's right there in the chat. So we think of brave, we think of knights. What else comes to mind? Sisu, vulnerable, taking calculated risks. So those are great. And if you click on the poll everywhere link, we're going to have several interaction points. So it'd be great to have what you say in there. Lions. So all good answers here. Let's see. Fearless, knights. Lots of different things that come to mind when we're thinking of courage. And that's what this talk is going to be about, is looking at how we bring courage to software development. I will mention I have a book, which if you're attending this talk, you can go to that URL and get a free copy of it online if you're interested. Also, there is a link right there to YouTube channel. It's got a bunch of Agile cartoons on it, which a lot of teams have found is a useful way to kind of discuss Agile with their teams. So with that said, my family and I were driving through huge snowflakes, and which was good because we were going skiing. So we were looking for a parking space at the base of the ski mountain in Steamboat Springs. And we pull in and I see this sign. It says park courageously. Now I had never seen a sign like this in a parking lot before, but I took the challenge. So I prepared to park, and I parked like I had never parked before. If the lady at my side had not stayed my hand, I would have vanquished every other one of those cars into the abyss. Or that was kind of the feeling I was getting. And if you think that sounds a little bit kind of like a Don Quixote moment, you're absolutely right. So as we left the car, and everybody was wondering what Daddy had just done, why was he parking like this, and I was feeling like I had really done something, we went by the sign again, and I realized I had horribly misread it. It actually said to park courteously, which was a far cry from what I had actually done. This got me to thinking a little bit about the term courage, and to me, it had all these thoughts of knights and fighting and vanquishing foes and stuff. But it got me thinking of, how does courage actually apply to my job? How does it apply to software development? And so this was percolating in my mind for a while, and I started doing some reading on courage, and there was a very interesting Socratic dialogue where these parents are coming to Socrates and asking him, how can we make our kids brave? How can we help them have courage? And he kind of talks through some things, and he makes an interesting point that if you have no fear at all and you're just completely reckless and just rush out into battle, kind of like, I think it was Richard Lionhearted that was known to rush out in battle and forget to put on his armor first, at least once or twice. That's not really courage, because you're not going to last very long in that type of thing if you just have no understanding of the risks that you're facing. On the other hand, if you're so scared of doing anything that you never actually take any risks, that's not courage either. But being courageous does not equal being reckless. So that brings us to our topic of courageous software delivery. And if we're looking for good models of courage, probably the best place to start is Star Trek, obviously. Okay, so this is Captain Kirk and Scotty, and they're having a conversation, like many of the conversations they have, and Captain Kirk needs more power. Scotty says there is no more power to be had, and the ship's giving us all that she's got. And Captain Kirk says that's not good enough because they need to get away from the whatever it is that's chasing them. And so Scotty comes up with a plan. He says, okay, I've got a great idea. We can reroute all the power from the self-composting toilets, apply it to the shields and to the engines, and we'll have just enough power to get away. The ship's going to smell horrible for the next 6 months, but I think this will work. Captain Kirk says, okay, how long will that take? And Scotty says, it's 2 lines of code. It's really easy. I can make this change just in about 15 seconds. Captain Kirk says, that's great. Go make it happen. And Scotty says, well, while I go change the code for 15 seconds, I need you to go talk to change management, because they're going to require at least 6 to 8 weeks of testing and paperwork before they allow me to deploy this code. So tune in again next week to see Captain Kirk battle the forces of change management. Now, my question for you here is, would you watch this show? Okay, if this was the plot of many of the Star Trek shows, is this something you would actually watch? So let's see this on the poll. How do you feel about this? Would you watch this show? The link is the poll everywhere link that Pika just posted. Okay, so yes, some people would watch the show. We kind of predominantly hear people are saying no. Maybe once or twice. That's probably the camp I fall into. And then we've got 20% of people that are diehard fans and will watch every single show while wearing their Spock costume. But the majority of us, the 41% of us, are saying this probably isn't the type of thing that really is what we're going to want to watch. And interesting question is why? Why would this be something? What, you know, if we like Star Trek, and I'm assuming a lot of us probably have enjoyed Star Trek at least at one point, why is this not what we'd watch? And I'd say it's because this is not the future, right? We assume that the enterprise has figured out how to deploy their code, and that's not the things we deal with in a day-to-day basis. We have this idea that on the future, that's not going to be the main struggle that we're dealing with. So a lot of these examples I want to talk through here are examples from a project I worked on and other projects, but a lot of them come from a project I worked on with the US government, where we went from a 6-month deployment process of a very important system, and they deployed every 6 months, often to catastrophic results. And we got that down to where for the past 5 years, they've been deploying every 7 days. Now, it's not that they're constrained to deploy to production every 7 days, but they that's just what they've done. That's the pace of their development. They can get to production in just a few hours while following the full change management process if they need to. But their pace is just every 7 days, new code is going on into production for the past 5 years. And this is a government system that's very important, and if it messes up, it wreaks huge amount of havoc. Process deals with about $10 billion a year, probably more now in payments in the government into agencies that the government is paying. So here's our outline for today. We're going to talk about lowering risk, and then we're going to talk about selling lower risk to change management. So first, let's start with you know the 6 months with disastrous results. So other people have felt that pain as well, right? So first, we're going to talk about risk. I'm going to divide risk up into 2 main areas. We're going to have changes to the application, so development risk. This is a risk that we change something in our code and bad things happen. The application does something that we don't expect it to. Next, changes to the environment or deployment risk. Maybe our code's fine, but when we deploy it, it deletes everything in the database. You know, that's deployment risk, or it doesn't deploy correctly, or some server doesn't come up like it's supposed to. So we've got change to the application risk and changes to the environment risk. So in talking about mitigating risk, we'll start with changes to the application or our deployment risk. One of the biggest ways to mitigate this, everybody talks about it, oftentimes I see it doesn't get done, is actually test-driven development. Test-driven development doesn't just mean that you have tests. It means that you're driving your development with tests. You end up with a loop that looks something like this. We write a simple test, we watch it fail, we write code, test eventually passes when we get the code working. Then, and this is an important step a lot of people skip, we refactor, where we stop and say, I got this to work, but is what I did sane? Does this make sense? Will I be happy with myself 6 months from now when I come back and look at this code? And if not, we refactor until we are comfortable with it, always checking the tests, and then move back up to writing a simple test. So most of us are familiar with this. I find this is a discipline like exercise or a lot of other things that it's easy to say we believe we should do this, but a lot harder to actually do this in practice. The other big thing in lowering risk that the application is going to do or the application risk is behavior-driven development. Behavior-driven development is similar to TDD, but instead of from the bottom up or from the developer's perspective up, it comes from the top down of how the user actually would interact with the application. So we have a loop that looks something more like this. We write a scenario, we watch it fail, and the scenario is, here's how the user expects, what the user expects to happen, an executable specification of what the application needs to do from the standpoint of somebody that cares about the application. We make that executable, it should fail. We're then going to write the code. Eventually the scenario is going to pass, and then we go on to the next scenario. If we put these 2 things together, we end up with something like this. We've got a BDD loop on the outside defining the behavior from the standpoint of what the user expects from the application, and we've got a TDD loop on the inside defining things from how the developer expects the individual pieces to work. So these together, if you build an application and this is what's driving all your code, you end up with a very, very well-tested application. You also end up with a very well-designed application, usually with very little gold plating because everything's being driven very, very carefully for exactly what the user wants in the language of how the user speaks about it. So this could be a whole talk right here, but these two things make a huge difference in getting rid of the development risk from our development process. Next thing, continuous integration. So most of us are probably familiar with this. It means that we're checking to make sure that our stuff all works. All those tests that we just mentioned, we run them on a regular basis whenever we make a change. Continuous integration. Discovering a problem in 20 minutes or 2 minutes instead of 2 weeks later. Next area of lowering application risk, very small changes. We're never going to be able to completely remove risk from what we do, but we can remove how much risk we take on at one point. If we're dealing with 2 changes, there are 2 points of interaction. There's 2 ways that these things can act. If we're dealing with 6 changes, we're now up to having 30 points of interaction. If we have 12 changes, we're now dealing with 132 points of interaction. Which of these would you rather try to troubleshoot? If you're looking at this thing right here, let's say there's a problem where the green arrow is. Would you rather try to troubleshoot that with this over here, where you just got 2 things you're dealing with? Or would you rather try to sort through this, let's say it's 6,000 lines of SQL code that's going live all at once? If we're dealing with the thing over here, where we've got the very small thing, we may be able to even look at the code and just say, this doesn't look right. We shouldn't do this. If we're over here, there's a big chance that something bad is going to happen. So which of these represents your deployments to productions right now? And I'm guessing we're going to skew. It'll be interesting to see how we skew on this. So which of these represent your deployments to production? So we've got some in both camps. And there's a huge gamut between these 2 things. And it's not that one of them is right or wrong, but one of them does represent more risk. If we want to lower risk, we want to move toward these simpler deployments in order to have fewer things that could go wrong at one time. So in looking at this, this example right over here, if this looks scary, it should, because this thing is, bum, 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 bum. That's the Death Star, right? You're deploying the Death Star. And that thing right there, that little problem right there that we were looking at is the exhaust vent. If something goes wrong there, the entire thing comes crashing down. Okay, so if we graph this out, we're going to have something that looks like this. We've got risk up and down and simplicity of change across the simplicity of what we're deploying across the bottom. The simpler we can make our changes, the lower we have risk. And I want to point out that the simplicity of change is necessarily tied to our deployment frequency. If we're wanting to have small changes, we have to deploy frequently. Unless you're in a situation where you can change 2 lines of code and wait 6 months to deploy it, most of us aren't in that situation. So if we want to deploy small changes, it has to be frequent. And this is what we're looking at. We want to get away from there. We want to move over here to where there's fewer changes. That brings us to the idea of continuous delivery. Continuous delivery is every change is proven ready for production when it's delivered. You'll hear both these terms, continuous delivery, continuous deployment. Continuous deployment means that when the change is proven ready to deliver or proven ready for production, we actually deploy it to production. Oftentimes, the biggest difference between these is what your change management process is. A lot of places will have you where you are required to have somebody from a different department be the person that pushes the button. You can automate everything, but it has to be somebody else that pushes the button, and it has to be a person that does it because we want to have somebody to blame. But I wouldn't get too caught up between whether you're doing continuous delivery or continuous deployment. The point is you want it all automated and as smooth as possible so you can deploy very small changes, and the overhead cost of these small changes doesn't prevent you from actually deploying them. Everything we talk about here, I want to point this out because oftentimes when I'm consulting with people, oftentimes I come in and we're really focused on one piece of things. And I want to point out that all of this stuff has to happen together. We can't just say we want to focus on behavior-driven development. You have to have the build automation and stuff above it to take advantage of it, and you have to have the things down below it to actually feed into it. So if we start with our goal being rapid and safe deployment of delivery of value, we need build automation, continuous integration to deliver that. We need BDD and TDD to actually have something to automate. We need story creation, sizing, and small changes to get to where we can deliver small changes. And down at the bottom, we've got the basic Agile values and principles. And that book at that URL we posted earlier starts right there. It's at the very bottom of, let's make sure we get this part right. It may be useful. It's a really good look at why, or I feel it's a good look, I wrote it, at why we do different things in Agile and not just doing the things, but here's the reasoning behind it so you know when to change and adapt it for your situation. Okay, so here's this graph. Keep this graph in mind, right? We've got risk up and down, deployment frequency. If we can deploy more frequently, we can deploy smaller changes and we can lower our development risk. So now let's move on. We talked about changes to the application. Now let's talk about changes to the environment or our deployment risk. Usually companies tend to graph this out risk like this. So over here, if we do this once, we'll get everybody on deck and hopefully nothing bad will happen. But the more often we do this, eventually, if we do this long enough, eventually something bad's going to happen. We're going to have this, explosion, something bad. And this is from NASA's website. I was looking for rocket explosions. They actually don't have any rocket explosions. They call these anomalies. And that particular one was called a catastrophic anomaly. So if we graph that out, it will look something like this. We've got, move on here. There we go. Okay. We've got our single launch. We're really, really careful, and one launch goes good because we've got everybody just focused on it. But if we do it enough, we know we eventually are going to have a catastrophic anomaly. Rapid unscheduled disassembly. Yes, definitely. So now we've got a conflict, right? We've got our development risk that is pushing us toward rapid deployment, and we've got our deployment risk that is saying don't do this very often. So if we put everything on the graph here, it looks like this. Most companies end up kind of splitting the difference here. They say, okay, we're going to pick something in the middle here and say, okay, we'll kind of average it out to where we think we don't have at the low point for this. And they may not consciously be doing this, but this is the type of thing that people are doing in their minds. And that's where you end up with it being deploying every month or every 6 months or even every year, because you're balancing these risks in making that decision. Let's talk about generators for a minute. And yes, this is actually going somewhere. Oh, I'm losing my my remote here. Let's see if this works better. Okay, got it. Let's talk about generators for just a minute here. My sister-in-law lives down in the Houston area in the United States. They get hit every once in a while with, with a big storm coming through. I talked to her after a big storm came through a while back, and she said that a lot of her neighbors were really excited. The power was out. Well, she didn't say they were really excited, but a lot of neighbors were pulling out their generators to run them that they had bought during the last storm or after the last storm, thinking that they wanted to have it when this, they wanted to have a generator for next time the power went out. And I imagine there were a lot of guys who had bought generators, had to explain to their wife why they were spending the money on this, and they were probably really excited that now they were going to justify their purchase. So they pull out their generators. My sister-in-law said many of the generators did not work. They'd been sitting in their garage for many years and never been maintained or never been exercised, and it didn't work, which was, I'm sure, a huge letdown for many people. We have a generator at our house because the power goes out here quite frequently. And every Wednesday, if you're on a call with me at 2 p.m., you'll hear a rumble in the background, and my generator starts up and runs through everything to make sure that it works and starts generating electricity. Whether we need it or not, it's going to run itself and make sure it works. I have high confidence my generator is going to work because that happens on a regular basis. Whether we think we need it or not, we regularly start the generator. But it's done with automation. And I want to point out, it's not just that we have the possibility of starting it, it's that we actually do it. And this is a very important thing to think about how we approach deploying, because we can start thinking that's so small, it's not worth deploying. But the value of deploying something really, really small isn't just the thing you're deploying, but it's exercising the process and making sure you're keeping it in working order and have worked out all the bugs. So which rocket company would you choose for a moon vacation? Would you choose they launch rockets twice a week and have been doing so for the last 3 years, or they launch a rocket once every 6 months for the past 10 years? Now, most people, we usually get a few people voting for B on this, but most people tend to want to be on the company that's done it many, many times very, very frequently. And if we look at SpaceX, that's exactly what they've been doing to try to get risk out of their system. And we think of the beautiful landing of their rockets coming down, and it's all beautiful and everything, but this is their, if you want to call it a blooper reel, or all the way that they got to the point that they're able to land these rockets, and that's pixelated because it's actually coming from a rocket. It's landing after landing that did not go right, and they kept doing it. I remember watching the news and thinking, are they ever going to get this right? But every single time they did this, they got more and more risk out of the system. So when you watch their rockets coming down and landing now, it's easy to forget that the way they got there was exercising it over and over and over again. And you can go look this up online. It's a little bit longer, and I like watching it. It's oddly satisfying because even if they run out of fuel and that's why they crash, they still blow up. They always blow up. And anyway, I encourage you to look at it. It's a great reminder to me that what we're trying to do is get risk out of the system. If we're able to correctly invest in automation and being able to deploy being able to automate our deployment, we can take this graph that looks like this and actually shift it around like that, which is what SpaceX did, right? They got and did things frequently enough that it's actually more risky for them to wait between, if they were to wait years between launching rockets, than it is for them to do it frequently. And that is the core of what DevOps gives you, is a way to lower risk by automating these processes so you can do them very, very frequently. So we talked about lowering risk. Selling the risk, this is often the easy part. Selling it to change management is often the harder part here. What I found in most situations when you're dealing with highly regulated organizations is that controls are usually your friend, but familiar culture is not. There's an example from San Francisco in the 80s. A bank there had cashed a bunch of checks that turned out to be fraudulent. They were all cashed by the same person, and the same teller was involved in the transaction. And they asked her why she kept cashing this person's checks from somebody that didn't even bank there. And she said he just looked so familiar. Well, after she had done it many times, he was familiar. But familiar does not equal low risk. And if we get too caught up on the way that we've always done it, the controls usually are actually your friend that will help you mitigate risk, but the way you've always done it in the past is not necessarily your friend. In some organizations I've found, this actually was the US government, we wanted to do rapid deployment, and we found that there was the idea of a standard change that let us change very few, as long as we were changing very few things, we could do things rapidly, but it had to be a small number of changes. But when we actually started talking to the change management people that actually had the governance over it, it turned out what they were really worried about was this. And this part of this, right? So if we were deploying version 2.0.10 to 2.0.11, that was fine because it was a low risk change. But once we tried to do this and we tried to deploy 2.0.10 to 2.1.1, and that was no good because that was obviously high risk because we had changed that middle number. This was okay. We deployed the application. A year later, we were on version 2.0.2367. They were very happy because we had only changed this last number. We were very happy because every single one of those changes was very, very small. And the value of it may have been political value of making sure we kept our numbers just this way, but it was a way for us to go ahead and do very small changes all the way through to production. Now, the value of this for this particular situation, this was a system in the US government that matches debts, make sure the government doesn't pay people to owe them money somewhere else. So there'll be like an ID number for someone and their name and debts and payments. We found that some of these systems were actually sending us the names where it was formatted wrong. It was the same person, but it was formatted, let's say it was all caps or something like that, just formatted a little bit differently, and it wasn't matching. When we discovered that, we went ahead and made the change and got the change through to production in about a week. It was a 2-line change, very trivial. We could run all of our tests and prove everything worked the way it was supposed to. 6 months later, I went back and asked what was the value of that change and was told it was $200,000 per week. So as a US taxpayer, this is a big deal to me. This is saving money. This eventually, at least should, lower my taxes. If we graph this out, compared to the previous situation where we were waiting 6 months to deploy it, once we discovered there was a problem here on the green line, we fixed it, right? And we weren't losing that money every week. On the other hand, previously, we would have maybe even fixed it, but couldn't deploy it for 6 months. The gap there was $5 million. That's how much money was saved just by being able to deploy a change and get value from it right away versus waiting for 6 months. So a lot of times we start thinking about the cost of rapid deployment, and we need to flip that around and really ask ourselves, how much is slow deployment costing us today? Now, all of this stuff comes down to leadership, and leadership is really key in making sure that we're able to deliver, to do any of this. So I want to tell you a story about leadership. And this is a story I think of when I think of leadership, because it's not your typical leadership story. This is a story about Jonathan. He was a 17-year-old in 2004 in Holland, Michigan. The Pirates of the Caribbean had just come out. Jonathan was discovering that he really liked dressing like a pirate, and there weren't a lot of opportunities to dress like a pirate in Holland, Michigan. So he came up with a plan. In Holland, Michigan, there is to this day still an annual Kinder Parade where it's mostly a bunch of kids walking down the street in a parade. There was at the time a single float that was in the parade every year, and it was the Makatawa Bank float, which happens to look like a boat. Jonathan thought this was a great opportunity to dress as a pirate and fall in behind the boat, because obvious pirate boat, this, he was stretching things here, but there weren't a lot of opportunities to dress as a pirate. So he talked to all his friends, explained his cunning plan, and they were all on board with it because they also want to dress like pirates. So they did that. The boat goes by, they're all dressed like pirates. They jump out from the sides and jump in behind the pirate, or the boat, not pirate boat, the boat as it goes by. Now, having been, most people don't know this about me, but I used to be a 17-year-old. It's true. I was a 17-year-old at one point in time. I've gone on to other things, but that I actually did that for a while. So as a former 17-year-old, I can explain to you that this sounds like a great idea. It's the type of thing that no one gets hurt. Everyone has lots of fun. It brings your friends together, and you get to dress like pirates. I mean, this is an awesome idea. Unfortunately, you're not actually allowed to do this at the Kinder Parade in Holland, Michigan. There are forms to be filled out, and there are processes to be followed. Anyway, Jonathan and his friends got arrested, or many of them got arrested. Most of his friends scattered when the police started coming after them. This is from the newspaper. There's Jonathan waving his sword in the air. He was actually quoted as waving his sword and not scattering, not running from the police, because he said he was going to go down with his ship. And there they are. They were I think their platform was they were protesting that the Great Lakes pirates weren't getting enough attention in feature films or something like that. This is where I became familiar with the story, was reading this in the newspaper. So they all got $100 fines. Now, having been a 17-year-old, I can tell you this is like a low point in your life. This is the type of thing that other parents will say, don't play with that kid. Remember the time when you got the $100 fine. Now, this could seem like a story about leadership to make sure you don't do the wrong thing because no one will want to be associated with you after that. But a few days later in the newspaper, I saw this. Jonathan had gathered up his friends again, and they were dressing like pirates and going to have a car wash to pay the fines that they had incurred for this seemingly great but ill-conceived plan to jump into the parade. And I like this line up here. It starts out with yo ho ho and a bucket of suds. Or I guess it's over here, sorry. Anyway, they got back together. And to me, this really exhibits what leadership is about. It's not about necessarily always guessing the right thing to do. It's about dealing with mistakes when they happen and rolling with it and turning it into something else, and not just giving up, but taking the things that go wrong and actually using them to improve and move forward. So when I think of the leadership that's going to be required to move us forward in software, this is a story I think of, not about just making the right decisions, but about actually dealing with consequences when things don't go the way we expect. So bringing this all back to courage and thinking back about Star Trek again, I want to encourage you to have the courage to actually lower risk in software development. And if we think about the future of what's going to get us to the stars and cure cancer and all these things, it's all probably going to depend on software in one way or another. And the things that we do in our daily, seemingly mundane life of dealing with software, the more we can bring courage to that in trying to do the right things and push ourselves forward as the software industry, we're building we're building the culture of how the human race builds software. And the courage that we bring to that is going to determine how well we do and how long it takes us before we get to the stars. So I want to throw a presentation feedback form up here. If you're in the thing, I'd love to get your feedback on what you thought.
Yeah, I just wanted to thank Mark for the fantastic presentation. It was basically half an hour to the minute, so very precise and nice content as well. I think we should go through some questions we had in the chat.
There is actually quite not so much questions. There is a lot of hype and energy and awesomeness, basically. Well, now there is one question. Not every change in the code brings value. Thinking of huge new feature.
Okay, so that's a great question. What I found is there's usually a piece of it that brings value, even if the value that you're bringing is just showing people that part of it works. So, for example, like the system I was talking about here, where we were matching debts to payments, there was some stuff where they came up with new ways where they wanted to use some artificial intelligence to actually match stuff up. So the first thing they did was just get a preliminary version of it running and just writing to the log file. And that's something they could do very, very quickly, but they could start getting the feedback and getting people to look at it. It wasn't even a system of record. It was just getting feedback of here's what this would do if we were to turn it on. So sometimes the value of getting something through to production is really high, even if it's just a small piece of it that you can just see part of what it does. Hopefully that helps.
Yeah. One actually question to you, Mark, from me. Do you know why SpaceX doesn't use any explosive bolts in their spaceships, Starship or Falcon 9?
Why they don't use any what?
Explosive bolts. So any kind of, yeah.
I do not know.
So they have designed everything so that it can be tested. So everything needs to be hydraulic driven or electric driven so that they can verify all the time, all of the mechanism, what is happening on the rockets. So that is like
very nice.
There is one question from Szilard, how to handle when dev and ops are in different companies and ops has its own 2 weeks of change management process for small changes.
Reminds me of the Phoenix project.
Yes. So unfortunately, there is a lot of effort right now in Agile to try to scale things. And I think the idea that we think we are good at scaling things kind of leads us to keeping those type of structures when they really should be broken down. So that's one place I think we've got a lot of improvement from the Agile standpoint, is making sure that we first try to make sure that we can efficiently deliver, and then look at how we need to coordinate between different teams. So the real thing is if you've got stuff separated like that, it's always going to be inefficient.
I agree with you. So about this first principle kind of thing. So we have a whole world is full of new ways to do things, and basically experiment with those, and then build the processes on top, and how you can collaborate on top.
I do not, except for yet another thank you for the great speech.
Yeah,
thank you.
I'm a fan now. So,
and if anybody, this link up here, if you fill that out, you'll get a copy of my book, but it'll also put you, I do lunch and learns on these type of topics. They're in the US, so may not be a great convenient time. But if you're interested in those, if you fill that out, it'll get you some of those invites.
There we have it. Thank you very much.
Thank you.